Alright, right now we're going to take a look at the dog walking problem, and as you can see, this is the problem right here that we have to go through. And basically it's a dog walking service that walks dogs, and they walk them all at one time, and they charge $5 an hour to do that. So what we need to do is we need to break this down into a problem statement. So let's go ahead and do that. And when we do that, we break it down into assumptions and input and calculations and output. And we always start with the output first because we know exactly what that is. So if I go down here, it says they want to be able to find out after walking a client's dogs how much they need to charge the owner. So we call that the final charge. And we can call it whatever we want, but that's what it is. And so that's our only output. And then what we have to do is we have to determine, how am I going to get that final output? Is someone just going to tell me what that is? If it's true, if that's true, then it's input. If it's something that never changes every time I run the program, then it'll be part of my assumptions, and we know that's not true. So I have to calculate the final charges. So what I do is I copy and I paste my final charges in here. And then I have to determine what calculation I have to do to get that final charge. And it tells us in here how they want that charge to be done. And that is the number of dogs. And I'm just going to call that num dogs. And we multiply that by the num hours. And we multiply that by the rate. Okay, so if I know that the rate is $5, the number of hours is whatever number of hours it is, and how many dogs it is, I multiply that together, I get my final charges, and that's going to be my output. Now, you notice I have the rate here, and the rate is $5 every time we walk the dog. So why wouldn't I put $5 there? Well, the reason for that is the $5, although it doesn't change every time I run the program, the user can call me back after 3 months and say, okay, well, we just raised our rates to 8. And we don't want to have it where someone has to go digging through our code trying to find out where the $8 is. So what we do is we put that up in the assumptions, and we put it at the end, and we say that the rate is equal to 5. And now everybody knows what the rate is. So now I know the rate. I don't know the number of hours or the number of dogs. And I have to figure out where am I going to get that from. Well, if the number of dogs or the number of hours never changes every time I run the program, then I would put that in assumptions. But it does change. Every time I have a different customer, we do a different number of dogs, a different number of hours. So my input is going to be, num dogs, and my other input's going to be the num hours. Alright, so I have covered everything. I know this is going to be my output. This is the calculation that's going to give me my output. And then I need to know where I'm going to get these 3 pieces of information. We determined that the rate does not change every time we run the program, so that's going to be part of our assumptions. The number of dogs and number of hours, that changes every time we run the program, so we're going to have to ask for that every time we run a program. We call that input. What's some of the other assumptions? Well, say we get that from the paragraph really, and say all dogs walked the same number of hours. And what's another one? Only one rate, and then that's the rate there. And that sounds good for now. Okay, so we don't have all that much. It's a pretty simple program. So this is what we call the problem statement. We break it down into assumptions, input, calculations, and output. And the question is, what do we do with it now? Well, now we turn it into a human algorithm. So what we do is we copy what we have, because we don't want to waste our time. Okay. Then we open up another notepad for the human algorithm, and we paste in what we had. Now, the assumptions at the very top, they have nothing to do with what we're going to be programming, so we're going to get rid of those. And now we start with this. Now, this assumption here, rate equals 5, well, that is something we're going to have to program. So that is going to be the first step. The first step is to document the rate as being 5. Okay, the second step is going to be some input. And the input is going to be the number of dogs. All right, then we go to the next input. And that's number 3. And the input, the number of dogs. And now we can get rid of all this, because the fourth thing we're going to do is we're going to do that math that the final charges are done. So we're going to assign the 5, ask for the number of dogs, ask for the number of hours, do this math, and then the last thing we're going to do is we're going to go ahead and output. And what are we going to output? We're going to output the final charges. All right. 5 steps to this program. Pretty easy. Okay, so the next step is going to be flowcharting this program, and I'm going to do that in my next lesson. So right now, what did we learn? We learned how to be able to do a problem statement from this problem right here. We started with the bottom, with the output, and then we moved up. We did the calculations, and then we said, well, where do we get these 3 pieces of information? And we said the rate doesn't change every time we run the program, so that's going to be an assumption. Number of dogs and number of hours, they do change every time we run the program, so they are going to be input. Then we copied all this, opened up our human algorithm, got rid of the assumptions that just give us scope, and started with our first assignment. And there's our 5 things. So I'm going to go ahead and say I'm done.